Welcome to NASA Edge.
An inside and outside look at all things NASA.
Today we're joined by Kevin Doherty from the TEMPO mission. Now, Kevin, can you first decipher the TEMPO acronym and then tell us a little bit about the mission?
Sure. So the TEMPO stands for the Tropospheric Emissions Monitoring of Pollution Instrument. It's NASA's Earth Venture #1, so we're the first of the Earth Venture instruments. And our goal is to put a satellite or an instrument into orbit that allows us to look at greater North America from a special orbit where we are centered over the same place on the Earth at all times. So we'll be able to see from approximately Puerto Rico up to the tar sands of Canada, and we'll be scanning from east to west once every hour during daylight hours to take a look at the pollution that's being generated in different parts of the country or different parts of the continent and how that transports across the continent. We will be able to see and measure pollution on the scale of about the size of the mall in Washington, D.C. So if you picture that and you think about going all the way from east to west, we'll get urban areas and rural areas alike and be able to actually fill in the gaps that are missed by most ground-based measurements.
Fascinating. Now, can you give us an idea of what kinds of pollutants you're actually looking for in TEMPO?
Sure. Some of them are ones that you wouldn't necessarily think of, like formaldehyde. But one of the big ones that we're reaching for is ozone. While we learn in school that you really want ozone at the upper atmosphere to help protect us from the UV rays that are coming from the sun, ozone down here where we live and where we breathe is actually very detrimental to human health. So that's just one of the pollution products, but we're going to actually be looking at a host of them, an ever-growing host.
Now, Kevin, who is NASA partnering with on this mission?
So the primary science institution is the Smithsonian Institution. They're actually the ones that will be receiving and analyzing the data and producing the data products for the world to see. Other partners that we have are Ball Aerospace, who built the instrument, Maxar Technologies, who built the spacecraft that we're riding on, and Intelsat is the company that'll be operating this communication satellite when it's on orbit.
And there's one other fact I think about this. Isn't this the first time NASA is flying an instrument on another spacecraft in this position? Is that right?
It certainly is. It's a new model that we're trying out with TEMPO. It's going to save taxpayers hundreds of millions of dollars to ride on a satellite that a commercial company is already building for themselves, instead of having NASA build its own spacecraft for this mission in particular.
Awesome. Well, we love hearing about partners. We love hearing about saving money. But speaking of partners, you work with a team, and that reminds me of competition. And as you know, we've worked on various shows together and demonstrated a little bit of competitive nature between us. And this time, for TEMPO, I'd like to say that we're finally going to discover who's smarter, who's better, who's the real winner. I think we're going to do that by checking out this brand new competition that should answer that question once and for all.
Welcome to Not My TEMPO, the show that is all parts air quality and no parts pollution. As usual, we have two contestants on our show. First up is Kevin. He is a TEMPO subject matter expert who has all the expertise and know-how to put a satellite in orbit. And second is Blair. Of course, we have our eco-friendly, low-carbon footprint panel of experts who will join us on our show today. We will learn more about our distinguished panelists later on in the show. Gentlemen, the panel will partner with you on today's challenge. Each of you will be given a word that may or may not be a gas or air anomaly that TEMPO will test for. You will have 10 seconds to extract your word from the panel with your supplied clues. For instance, if I were to say gaseous H2O, the panel would say...
water vapor.
That is correct, and a point will go on the board. If the clue is not a part of a TEMPO mission, the contestant should say...
not my TEMPO.
That's right. Sounds like you guys have played this game before. Remember, you cannot say the word or part of the word in your clue. Let's get started. Kevin, your first word is... 10 seconds on the clock, and go.
Although very beneficial in the upper atmosphere, this gas is harmful to humans down at the surface.
Ozone.
That is correct. 1 point for Kevin. That's a great start. Blair, you're next up. Your word is...
Wait, is this a word?
And go.
Can someone use this in a sentence?
Nitrogen dioxide.
Come on, Blair. Help us out.
TikTok, you're on the clock.
Country or place of origin? Or planet? I mean, is this Klingon?
Oh, I'm sorry, Blair. Your word was chlorodifluoromethane. Perhaps you got a little frustrated. No points for Blair.
Is frustrated even a word?
We'll be right back.
We're back, and joining us now, we have the principal investigator, Kelly Chance, with us, and we also have Dave Flitner from NASA join us. Thanks for being on the show, guys.
You're very welcome.
Kevin did a great job in our last segment talking about what TEMPO is very broadly. But I understand the science really started with you on this mission. So, Kelly, tell us a little bit about the origin of the TEMPO mission.
Okay, well, the origin goes back to 1985. And it wasn't just with me, it was colleagues from Europe who proposed a small satellite instrument that would do these kinds of measurements, but you would do them with a more limited range of wavelengths, and you would do them only once a day over most places in the world, and even that at very, very coarse spatial resolution. And there have been a whole series of those. Some wonderful successes, too. TEMPO seemed to be an obvious idea to try and concentrate here. So TEMPO will now measure Mexico, Canada, US, Atlantic, Pacific, every daylight hour.
Well, considering that unprecedented look we'll be taking at North America, Dave, I'm wondering, was NASA able to bring to bear some expertise in this area as we're working together on TEMPO?
Yes, most definitely. Certainly from just developing the instrumentation side, but also the science behind it. Also leveraging at the same time with the scientific instrument on a platform that isn't necessarily a place that NASA goes, a geostationary orbit. They don't typically have that in their fleet, but there's plenty of communication satellites there. And so maybe we could use a partnership there, use space available on a satellite that's already there. So kind of this hosted payload concept.
Yes.
And so NASA had already been looking at that kind of paradigm, which is much different from what is typically been done, as Kelly mentioned, the low Earth orbit stuff.
Well, to me, it's just interesting to see the partnership, the science that Kelly's talking about, and the opportunity of NASA working on finding that space to observe from. This seems like a dream team for looking at pollution.
It does.
And so, Kelly, I'm wondering, as we think about what TEMPO will be looking at, what are some of the pollutants that we hope to be able to study or see with TEMPO?
Well, the molecules of ozone first, nitrogen dioxide, halogen oxide, bromine oxide, iodine oxide, water vapor, formaldehyde, and I'm always missing one or two.
Bromine?
Oh, that was one of the halogen oxides.
Oh, sorry.
Bromine
Yes,
oxide.
I'm trying to impress you guys. I'm not doing a good job, but
That is one of them.
thanks.
That is one. So we had many years of experience in sort of pulling these out of the weeds in the spectra that we would take with the other satellites, the low Earth orbit satellites. So we had a real head start.
So Dave, from a NASA standpoint, what's the challenge of taking these scientific opportunities and working with the spacecraft and actually getting data that can make its way to, all the end users that are interested in the data?
There's many challenges, but I guess TEMPO brought on some other challenges that aren't standard in the way NASA has done missions, and that's trying to work with a commercial partner for the spacecraft. Trying to work within their standard practices, not disrupting their model and the way they do things. They're very good at what they do. They have a niche. This would be another avenue to allow NASA missions of science interest in places that we don't typically go to, or maybe lower cost. Overall, we're not buying the whole bus, we're just buying a ticket on that bus.
Could I be an early adopter? I'm very interested in looking at some of this data. I may not understand it, but
Okay.
But is it really conceivable that someone like myself, if I wanted to, inspired by Kelly's science here, I want to go look to the at the data. I don't know how to understand it, but I could sort of be a part of this and
Yes, you could be. Yes. It's publicly available. There isn't any cost that you have to pay for
Even better.
the data. I mean, in a sense, you have paid for it by paying your taxes. And yeah, so it's open to the public and beyond.
awesome. Well, my goal is to be on the list of people that receive the data. That would be Kelly, and then Blair, and then the rest of the science community. We'll see what happens, but thanks so much for being on the show.
Okay.
We're going to take a quick break, and when we come back, more on the science and operation of TEMPO.
Welcome back to round 2 of Not My Tempo. First, let's get to know some more about our panelists. Crystal and Eric have been on the show before. Thanks for joining us again. But new today are Donna, a heliophysicist from Sunspot, New Mexico. Thanks for joining us. And Lauren, a chemical engineer and mixologist from Piscataway, New Jersey. And finally, we have Stephen, a theoretical seismologist from Cleveland, Ohio. Thank you all for joining us today. Let's get started on round 2. Kevin, your word will be...
Animal specimen are preserved in this.
Formaldehyde.
And just like that, 2 points on the board for Kevin. Great job, team. Now, Blair, let's see what you can do. Your word is...
Is this the same word as last time?
And go.
Did someone just lean on the keyboard? This is
Blair, time is not on your side.
words that end with methane.
Azomethane.
Biogenic methane.
Spin the wheel of methane.
It's like 70 methane.
Oh, I'm sorry, Blair, but you can't use the answer in part of your clue. I believe we went over that extensively at the top of the show. The word was dichloro... We'll see if Kevin continues his dominance over Blair when we return for the third and final round of Not My Tempo. We'll be right back.
Joining us now is Dave Rosenbaum and Sandy Cellis, the Deputy Project Manager and the Chief Engineer for TEMPO. Now, I want to start with you, Dave. I'm very curious. You know, this mission, studying the pollution that it does, requires only one instrument, I believe.
That's correct.
How do you do it with just this one instrument?
Well, the instrument is a spectrometer, and it is designed such that it looks down on the Earth and picks up the reflected sunlight off of the Earth. That optical signal makes its way through a bunch of optical elements inside of a telescope, and that it enters through a particular optical element into our spectrometer. That data that gets focused down onto our detector, which converts the optical signal to an electrical signal. That electrical signal is then processed and turned into data bits that are sent to the ground to eventually the location where the science data processing occurs that creates the science products that Kelly and the rest of the scientists are interested in.
And so, for example, some of that data gets turned into, like, how much of this element or that element that you found is in the atmosphere.
That's correct.
Awesome. And so this data becomes very important. So, Sandy, tell us a little bit about the data itself. Once it comes down and it's gone through that process of turning into actual scientific measurement, where does it go?
So the SAO processes all the data products and submits them to the ASDC, which is at the Atmospheric Science Data Center here at NASA Langley Research Center. And the ASDC makes the information publicly available. They do that by a website called Earth Data Search. Also, the AWS cloud is where it's also kept and housed.
And so theoretically, and verify this for me, if I wanted to look at some data on a particular region, say Franklin's backyard, where he's been over-grilling, in my opinion, and I wanted to look at that area, I could just go to the website as a scientist or amateur scientist and get that data.
Yes, you're supposed to have subsetting capabilities, so you would be able to zone in to that type of information.
That's just fascinating. Now, obviously, putting together an instrument like this that gives this kind of data is a challenge. So, Dave, what challenges did you face along the way getting this instrument ready for flight?
As many as you could imagine and more. It ranges from everything you could imagine, from electrical to mechanical, structural, optical, command and control, thermal, and that's on the instrument side. And then eventually you have to integrate that on the spacecraft, which produces its own challenge because sometimes things don't go the way you planned there and you have to, again, adapt.
And so for you guys, from an instrument standpoint, all throughout the process, as the instrument's put on the spacecraft and makes its way to the Cape, you'll do your own testing to make sure everything's still operational before launch.
Correct. The level of testing that we did during instrument development was far more extensive in detail, but we continue with that at a reduced level at higher levels of integration for a variety of reasons. But we are making sure that the instrument works as it goes through the integration process, and there is a final functional test at the launch site before the launch vehicle is ignited.
Now, will you be participating in launch activities for Tempo?
There will certainly be a role for me to fulfill, I imagine, at the launch site.
Awesome. And how about you, Sandy? Are you going to be there for the launch?
Yes, yes, and I will be paying the bill.
And what very important process.
Yes.
And thank you guys for being on the show. We have to pay bills too, so we're going to take a quick break, and we'll be back with more Tempo in a minute.
Okay, we're down to our final round. And in this round, points will be doubled. And remember, all contestants with 2 or more points advance to the lightning round where coffee and snacks will be supplied. Okay, Kevin, you're up. Woo! Your next word is a tough one. And it is...
Oh, C2H2O2.
Wow, that's incredible. That was a record time in getting that answer. I've never seen anything like it. Blair, let's see what you can do to match it. Your word is...
Finally.
Ready?
Totally.
And go.
Its atomic number is 1. It's easy. It's H. If you get cut, you put blank peroxide on it.
Hydrogen?
Hydrogen.
Yes, like the Hindenburg, but different.
Oh, I'm sorry, Blair. Hydrogen is your word, but as we all know, it is not a gas that is measured by tempo. I'm sorry, but no points for you. Kevin is our undisputed winner for today. Thanks to the panel for joining us on today's challenge, and we'll see you next time on Not My Tempo.
Joining us now are Raed Suleiman and Robert Neese, and you guys are what I like to call the operations team for Tempo. And so I want to talk about this process of what happens once the data comes from the spacecraft and makes its way down to the ground station. So, Raed, could you tell us about the process of operations once we get started with Tempo?
Sure. So for the operation in the ground system on our side, we have 2 pieces. We have the Instrument Operations Center, the IUC, and the Science Data Processing Center. So the Instrument Operations Center, the IUC, that's what actually receives the data from the spacecraft to the ground station to us. It basically splits in, time order. It cleans it up, that's raw data to level 0, and piped it to the Science Data Processing Center, where all of the data products goes from level 1, level 2, level 3 data products.
This is a very important system to get this to you and process that data. But you worked with NASA, right, Robert, to actually make this pipeline possible. Talk about how this came about.
Okay, well, I'll start at that end. So the IOC does the commanding and the communicating with what we call the host ground system. So we have bought a ride on a commercial satellite. It's a communications satellite, and Tempo just sits on that and stares down and scans the Earth. And so we have to use their system to bring the data down to the ground, and it passes through their ground system. And the IOC is very automated so that it picks up that data automatic, and it will just constantly pick it up. And it comes down at a high rate. And the host ground system accumulates 3-minute chunks of data, puts them in files, puts them on a server. They pick it up and do all this processing that has been described to you. And the IOC communicates to the SDPC, passes on the science data, sorts out the health and status data, and monitors the instrument and that kind of thing. So in terms of getting all this to work together, they were out ahead of acquiring a host. So before we knew whose satellite it would be or whose ground system it would be that we would deal with, they're developing their ground system already. So one of the things they had to do was to plan it so that they could interface with someone where they might not know exactly what they were going to get.
Wow.
So when we did get a host lined up and all of that, we started to resolve the problems of communicating to them what our interface would look like and understanding what we might have to change to work with them.
Yeah, it's actually kind of an interesting a path that you have to take to do these things, because as I understand also, Raid, that Kelly and the science team and you and the science team have an opportunity to look at specific areas. So you have the general parameters and data that you're gathering for the mission, but you have this ability to do these special observations, and that requires you to communicate with the spacecraft.
Yeah, absolutely. So the idea our mission is going to be quarter of it covering these special observation. 25% of our data will be within the special observation. So now we generate the commands that's similar to the commands where we will cover the whole full field of regard for 1 hour. However, it's only looking at this specific region.
And you work with that science team to identify the time and place to do that.
Correct, and that will be predetermined because you will know about these campaigns in ample time. However, there are events that happen that we don't know about it. You can't schedule a wildfire, obviously. You can't schedule when Mount Helen volcano will explode or something. So the idea of something like this happen, you want to be able to react to it and generate kind of or do the same observation to look at the same area of interest.
See, the science team, this is where they get excited, doing these special observations, because it's when they get to be creative. You know, the routine collection of data, which is 75% of the time, will give them a large database to start from. But this is where they can team up with other scientists, groups that are doing different research, and there will be people approaching them that have ideas how they can use the Tempo data, and these guys get on board with that.
I bet that 25% is going to fill up really quickly.
It is. It will fill up pretty quickly, and there are significant things you would be interested in doing.
Yeah, sure.
Within the whole hour observation window, the whole field of regard.
Tell you what, it sounds like, from my perspective, there's going to be a lot of exciting data, and especially for this 25%, I might try to get in on one of those opportunities.
Absolutely, yes.
Well, thanks so much, guys, for being on the show. We're looking forward to successful launch and lots of data from Tempo.
We are too.
We are too, and thank you for having us.
You're watching NASA Edge, an inside and outside look at all things NASA.
You'll be in the lightning round next time?
Yeah. Glad to have won.
Yeah, you were flawless. Flawless victory.
Not here. The word is not even in the dictionary. In the dictionary.